Good morning to Dr. Ilya. Today, our group are going to present PSDA Project 2. My name is FION, and along with my teammate Xuan, Xuan, and ZOEY. The topic for our Project 2 is the factors that influence students' final academic grade using the Student Academic Performance Dataset from Kaggle. Then the goal is to take on theoretical statistic knowledge into meaningful real data through RStudio so that we can execute an inference-based analysis in a manner that is representative of real patterns and behaviors in student learning. Then we have two aims in this project. First is to use statistical test analysis on the secondary data source. And the second is to assess the dependency relationships between the selected variables of interest in the dataset. Then the dataset utilized for this project is titled as Student Academic Performance Dataset. Each student presenting a unique response collected based on the structure questionnaire on academic engagement and performance. And the following is the link we get our dataset from. The population represented by this data is secondary and post-secondary education students. From this population, the dataset provides a sample size of 1,000 students. This dataset includes 15 variables such as student ID, name, gender, age, grade level, math score, reading score, writing score, attendance rate, parent education, study hours, internet access, lunch type, extra activities, and final result. These variables are a mix of categorical and quantitative data type. For example, student ID, name, gender, internet access, lunch type, extra activities, and final result is categorical, and the level of measurement for those variables are nominal. While the grade level and parent education is categorical, but the level of measurement is ordinal. The last is age, math score, reading score, writing score, attendance rate, and study hours. These variables are quantitative and ratio for level of measurement. The following is the statistical test analysis. So the first one is one sample hypothesis test on mean, variance, and unknown to determine whether students' average math score differs significantly from the population mean of 75, and the variable selected is math score. By conducting a one sample t-test, we can determine whether the mean of the student average math score is significantly different from the population by 75. If p-value less than 0.05, we reject null hypothesis and conclude that students' math performance is significantly different from the average. Then the second is correlation analysis, and the variable selected is math score and reading score. It's to determine if there is a linear relationship between math and reading score. By calculating the correlation coefficient between math score and reading score, we can examine the relation between math and reading scores. If correlation coefficient is significant, which is p less than 0.05, we conclude a linear association exists between the scores. Then the third one is simple linear regression test. And we have selected study hours and math score as the variables. And the objective for this test is to determine if study hours can predict math scores. By performing a simple linear regression analysis, we can determine the relationship between study hours and math score. A significant regression coefficient, which is p less than 0.05, suggests study hours are a predictor of math performance. Then the last one is chi-square test of independence. It's to determine if academic result which is pass or fail, is associated with gender. Then the variable selected is gender and final result. By conducting a chi-square test of independence, we can examine if there is an associated between gender and final result. A significant p-value which is less than 0.05 suggests that academic performance is dependent on gender.
Okay, next we have data analysis. Okay, first is hypothesis one sample test. Okay, this analysis tested whether the average MET score in the sample population is significantly different from the hypothesis population mean of 75, the two-tailed t-test. The alpha is 0.05. The null hypothesis mean is 75, while the alternative hypothesis mean is not equal to 75. The sample size n is equal to 1000 students for our datasets. The mean MET score is 75.165 points. The standard deviation of the MET score S is equal to 14.3043. The alpha is 0.05, while the degree of freedom (df) is equal to 999. So the result we get is, since the test statistic is lower than the test critical, 0.3648 is lower than 1.9623. So we fail to reject the null hypothesis. We can see the degree of freedom is 999. The t critical is 1.9623. So our get a test statistic is 0.3648. The sample mean is 75.165, and the population mean is 75. So we get fail to reject the null hypothesis.
Okay, so next we have correlation test. So for the correlation test, our objective is to examine the existence of a linear correlation between students' math score and reading score. We want to test that is it the student who score in maths also score in reading, or students who good at math are poor in reading. So for this correlation test, we have our sample size, which is 1000 students, and for the variables, we use students' math score and students' reading score. So for the hypothesis, we use p equals to 0, h now, p equals to 0, which means no linear correlation. And the alternative hypothesis h1, p not equal to 0, which means linear correlation exists. So we have conducted a scatter plot here, and we have our R, which is negative 0.039, which which we obtain from this equation. And also we have our test statistic, which we use this equation to obtain the test statistic. So we obtain that the value of R is negative 0.039, which indicates that there is a very big negative linear correlation between the variables. As negative 0.039 is very close to 0, so it concludes that there is no linear correlation exists between students' math score and reading score. Based on our two-tailed t distribution graph here, we can see that the test statistic, which is the green line, is not in the critical region. Therefore, we fail to reject the null hypothesis, H null. And since there is no in conclusion, there is no sufficient evidence to conclude that linear correlation exists between students' math score and reading score. Okay, for the third one, we have our regression test. For regression test, we intended to determine if study hours can predict student math score. We want to know that is it the more the study hours, the better the math score of the students. So for this, we have our sample size, which is 1000 students. And for the variables, we use student study hours and students math score. So for hypothesis H now, for beta 1 equals to 0, means that there is no linear relationship between both variables. And beta 1, H1, beta 1 not equals to 0, which means that linear relationship exists between both variables. So based on the scatter plot here, we found that the sample regression line, which is y equals to 74.386 plus 0.262x, indicates that the average math score of a student increased by 0.262 score for each additional hour of study. So 74.386 here is the y-intercept, and 0.262 here is the slope of the line. The coefficient of determination R-square, which we get from the formula, is 0.00046, which is almost 0. So it shows that there is no relationship between the both variables. It means that there are only 0.046% of the variation in math score that can be explained by variation in study hours. So based on our two-tailed t-distribution graph, the test statistic is not in the critical region, which is the green line. The green line is not in the critical region. Therefore, we fail to reject the null hypothesis H0. In conclusion, there is no sufficient evidence that student study hours affect their math score, and we cannot use the study hours to predict the student's math score.
Now I'll present the last test, which is chi-square test of independence. Our objective is to determine whether the academic results, pass or fail, is associated with the gender. So there are two variables, which is gender, example, male, female, or other. And the second variable too is final result, which is pass or fail. This sample consists of 1,000 students from student academic to performance dataset in table. The null hypothesis is there's no association between gender and final results, which is independent, and alternative hypothesis is there is an association between gender and final result, which is dependent. So here's the contingency table, which summarizing the observed counts. For example, 160 female students failed, while 166 students passed. The totals are balanced across the genders using a significant level of 0.05 and degrees of freedom calculated as 3 minus 1 times 2 minus 1 equals to 2. The critical value from the chi-square table is 5.991 from the chi-square test table. And the chi-square value is 0.203, which is calculated as the sum of square difference between observed and expected counts divided by E, which is 0.203. So here's the expected counts. Next slide. So here's the chi-square distribution table, and this graph illustrates the test statistic, which is 0.203, falls in the non-rejection region. While below is the critical value 5.991. So this decision, since the test statistic value is smaller than critical value, as stated 0.203 is smaller than 5.991, we fail to reject null hypothesis at the significance level of 0.05. So the conclusion here is there's no significant relationship between gender and their final academic results. This suggests that gender does not influence whether students pass or fail in this data set. Next slide. So now I'll continue with the conclusion. By completing this statistics project has allowed us to understand the different elements that involve the academic performance of students. We used real data and had a strong experience utilizing different ideas of statistics with sample hypothesis testing methodology, correlation, regression, and chi-square test of independence. The one sample t-test and the assumptions of its provided basis for showing that the average math score of the cohort statistically differed from the population mean. Overall, that the academic expectations may have shifted. The second key statistical approach revealed a linear positive correlation between math score and reading scores, suggesting that one's performance within one subject area may be related to performance in another subject area. A third approach was by using regression analysis to show that quantities of study hours were a significant predictor of math performance, which indicates the importance of the academic effort. The final methods of the chi-square test also was an interesting approach showing the differences between gender variable and academic outcome. We also observed that gender may suggest differences between typical rates of passings. Overall, this project helped with understanding of the process of testing and analyzing using statistical tests amid the RStudio experience of coding. Importantly, we learned how to assess and interpret and understand the aspect of the data that we analyzed and computed, and developed interest and appreciation for using data in educational research. We want to sincerely thank Dr. Nur Ilya for her focus and encouragement through the project. Thank you.